All right, I've been playing around with Assembler recently and GWBASIC, and I realized that I needed a new tool, and that's basically a binary to be saved tool. And the reason for that is I've been trying to integrate some code into GWBASIC, and so I've been creating a conf file, then converting the conf file to binary, and then loading it up into GWBASIC and renumbering, and that turned out to be a pretty big hassle for me constantly doing that. So I realized if I saved it as a bsave file, the conf file, I could easily just load it up with a couple lines. So I would have a pre-allocated array, and which is bigger than any code I would generate, and I would get the address here and just be loaded specifying the address, and that would work just as well as the method I was using before. So that saved me a lot of time. And there's also a second purpose we can use the binary to be saved, and that's to load graphic images. So I'm going to give you a little demonstration with that. So you've seen me use my little editor here before. Let me just bring it into view. I created this new character just for this video, and let me save it. Now I could generate the code automatically, but I'm going to save it in a format that's not the code. So let's select a put file. And now I think I've done this with QuickBasic and QBasic. I have some code that allows you to read this, but it's not using the load command. So what we're going to do here is just save it as a put file. And let me just call it image.xgf. So that's easy for me to remember. We're done with you. We'll put you on the other screen. And let me just scroll through the, here we go. I called it test before, but this time I saved it as image. And our result file will be image.bsv. And let's just run that. Let's take a look at the size. And we have two files, the original file, which is 68, and the bsave file, which is 82 bytes larger. So the size you should be creating for your array basically is half the size of 82 minus 14 bytes, basically. And if we convert that to integers, that's half the size. So let's say for our file right here, we should be creating an array that's trying to do math in my head and do a video. That's not working for me. Let's pull out the calculator. All right, so 82, which are one decimal, 82 minus 14 equals 68. Divide that by 2, and 34 for our array size. So let me just load up GWBASIC now, and I have a program already written, and I'm just going to load that up. And so if I leave it the way it is, it'll still work because my array here is much bigger than our image. So let's try that first. And if we take a look, it looks just like our little picture we exported. Now that, to show that it actually just works, let me change the let me change a few things on this thing. Let's make the hands and feet also pink, and we will resave it. Okay. Now, if we run this again, it's not going to show the updated image because we haven't converted it yet. So let's exit and just rerun our command line. Go back. And run. And there we go. We have our updated image. And if we do a listing here, if I change our array size, remember I said, let's bring up the calculator again, because I think I already forgot what the number should be. And so it should be 34. So let's change the number here to 34. And we should be able to run it without any errors. Here we go. There we go. Okay, so that works. We're done with that. Now the other utility that I've been using is the binary to source. And once you're finished with your bsaving and testing, you might want to convert that binary to data statements to include in your final basic program. That way you only have one file, no chance of losing your additional data files. So there's a use for that as well. And let me just demonstrate that. And here we have a whole bunch of options. And so we can generate not only data statements, but C and Pascal constant arrays. But for now, I'm just going to stick with GWBASIC or BASIC generating. And if we used our sample image that we just saved, let's try image dot xgf as our source, and we call it image dot bas as our output file. And let's specify basic and we should specify the format first. So let's put in the Word format, which is the same as integer in BASIC. And let's put BAS for data statements. And let's just see what it creates. So if we do a type on this, image.bas, we can see that it generated these. And we could read these constants into an array and display the image the same way. Now we could also, let's say this wasn't a picture, let's say it was some kind of other file and we wanted it to be read as a string. We can change this to byte here. And if we take a look now, we can read this into a string and add each string one by one. But we could also let the utility do this work for us as well. So instead of typing BS, if we type BS2 and take a look now, it adds the strings together for us. And it's missing line numbers, so we could also specify that we want lines. And if we do dash lines and take a look now, we can see that there's line numbers. And if we don't like the default line number starting point, we can specify a starting line and increment by 20, let's say. And it does that for us. And let's say we want to go back and change this to Word. And let's see what it'll generate now. So it does the same thing, but it manually assigns each item to an array index. So it starts at 0 here, then assigns it to 1. Now, this is the code I would eventually use to convert the assembler to an array and do it this way. This way I don't have to read each one. All I have to do is just basically reference this. And so as my final way of including the assembly program into my program, I would use this method. So that's basically how these programs can work independently or together. So hopefully this isn't too confusing, but this is the easiest way for me to document things, as writing documentation takes a long time for me. So this is the quickest I can do at the moment. Later on, hopefully I'll have actual documentation on the GitHub, and you can follow along there. All right, that's it for this video, and thanks for watching.